Hello everyone and welcome to Numerical series of electrical machine. And today our numerical problem is an iron ring has a cross section area 2 centimeter square and a mean diameter of 20 centimeter. An air gap of 0.5 mm has been cut across uh, across the section of the ring. The ring is wounded with a coil of 300 tons. The total magnetic flux is 0.20 milliweber. The relative permeability of iron is 1000. Find the value of current passed in the tons. So area given 2 centimeter square. Convert this into meter. Then 2 into 10 to power minus 4 meter square. And diameter equal to 20 centimeters, so 2 into 10 to power minus 2 meter. Total length, this is a circular, so total length equal to 2 pi r. Then pi into d, 2r is in the place of 2r we can write d, that is mean diameter. Then put the value, then you can get total length equal to 0.628 meter, and the length of air gap is 0.4 mm, so 0.4 into 10 to the power minus 3 meter, and number of turns is 300. Magnetic flux is 0.02 milliweber, so 0.2 into 10 to the power minus 3 Weber, and mu r is 1000. Relative permeability is 1000, so mu r equal to 1000. And total EMF, we know total EMF equal to EMF of iron plus EMF air gap, so EMF equal to Ni, and EMF iron equal to Si into Li plus Sg into Lg, that is air gap, and this is iron. So then value of N is 300 into I, and we can write in place of S B upon mu naught mu r, and place of Li Lt minus Lg, total length minus length of air gap. Then you can get the core length of iron core. And similarly for air gap, B upon mu naught mu r into Lg, then 300 into I, phi upon A. In the place of B we can write phi, B equal to phi upon A. This is the value of B. Then replace the value of B in this equation. Then 300 into I into 0.2 into 10 to the power minus 3. This is phi, and this is total length minus length of air gap, plus, and by 4 pi into value of mu naught 4 pi and value of mu r 1000. Area is 2 into 10 to the power minus 3. And again for air gap, phi is same, so 0.2 into 10 to the minus 3 into L, the length of air gap is 0.4 into 10 to the power minus 3 upon 4 pi into 10 to the power minus 3, and the value of mu r for air gap is 1, into area is 2 into 10 to the power minus 3. By calculating this we can get the value of I, and the value of I is 2.72 meter. And the next problem is, an iron ring has a cross sectional area of 3 centimeter square and mean diameter of 25 centimeter. An air gap of 0.4 mm has been cut across the section of ring. The ring is wounded with a coil of 200 tons carrying the current of 2 ampere. If the total magnetic flux 0.2 milliweber, find the relative permeability mu r of the iron. First of all, write all the given data, and the given data is area equal to 3 centimeter square, so 3 into 10 to the power minus 3 meter square. And mean diameter is 25 centimeters, so 25 into 10 to the power minus 2 meter. Total length equal to this is the circular, so 2 pi r. And then in the place of 2r we can write d, then pi into 25 into 10 to the power minus 2 meter, then we can get 0.785 meter. And the value of n 200, I is given 2 ampere, and the value of length of air gap Lg is equal to 0.4 mm, so 0.4 into 10 to the power minus 3 meter, and phi equal to 0.24 milliweber, so 0.24 into 10 to the power minus 3 Weber. And again total EMF equal to EMF plus iron and EMF plus EMF air gap. Then in the place of EMF we can write EMF equal to Ni, and for this we can write this formula, Si into Li plus Sg into Lg. then B upon mu naught mu r plus LT minus LG plus B upon mu naught mu r into LG. In the place of B, we can write phi upon A. Put in the place of B phi upon A. So phi equal to 1 by mu naught mu r A Ni upon into LT minus Lg plus Lg. Then put all the value. We can get the value of mu r, and the value of mu r is 3484. Relative permeability is 3484. Similarly, the next numerical problem is a steel ring has a mean diameter of 20 centimeter across the section of 25 across section of 25 centimeter square and radial air gap 0.8 mm cut across it. When excited, a current of 1 ampere through a coil of 1000 tons wound on the ring core, it produces an air gap flux 1 milliweber. Calculate total reluctance of the magnetic circuit and the relative permeability of steel. Mean diameter 20 centimeters, so convert 20 into meter. Area is 25 centimeter square, so convert this area into meter square. L, the length of air gap 0.8 mm, so 0.8 into 10 to the power minus 3 meter. I 1 ampere, N 1000, phi 1 milliweber, so 1 into 10 to the power minus 3 Weber. Total length equal to 2 pi r. Put the value of and then in the place of 2r you can write d. So put all these value, we can get total length, and mmf equal to mmf steel plus mmf air gap. So Ni equal to phi upon mu naught mu r a LT minus Lg plus phi upon mu naught a into Lg. Put all these value. Then after putting all the value, we can get the value of, by simplifying this, we can get the value of mu r, that is relative permeability, and mmf equal to phi into reluctance. So Ni equal to phi into S, S equal to Ni upon phi. Then put the value of Ni and phi, we can get the value of reluctance. The value of reluctance is 10 to the power 6. And similarly, the next problem is an iron ring of mean length 50 centimeter has an air gap of 1 mm and winding 200 tons. If the relative permeability of iron is 300, when a current 1 ampere follow through the coil, find the flux density. Take mu naught equal to 4 pi into 10 to the power minus 7. First of all, write all the given data. Total length equals 50 centimeter. So 50 into 10 to the power minus 2 meter. Lg equal to 1 mm. So 1 into 10 to the power minus 3 meter. And n equal to 200, I equal to 1, mu naught equal to 4 into 10 to the power minus 7. We know mmf equal to mmf iron plus mmf air gap. So Ni equal to B upon mu naught mu r plus LT already given, mean total length already given in the question, plus 1 upon mu naught mu r upon Lg. Then the value of B is 200 upon this value. Then 200 upon, put the value of Li Lg mu naught mu r. Then we can get the value of B, and the value of B is 0.094 Tesla. Similarly, our next problem is calculate the current required to produce a flux of 4 milliweber in the core of magnetic circuit shown in the figure. This is the figure. N equal to 1000, A equal to 10 centimeter square, relative permeability mu r equal to 400, and mean diameter is 25. So write all the given data here. Then we have to find the total length. Total length is 2 pi r. Put all the value, we can get the total length, and mmf equal to flux into reluctance. So Ni equal to phi upon mu naught mu r A into Lt. Therefore I equal to 4 into 10 to the power minus 3 into 0.785 upon 4 pi into 10 to the power minus 7 into 400 into 10 into 10 to the power minus 3 into 1000. Then we can get the value of current. In the question, we have asked calculate the current required. So the required current is 6.24 ampere. And next problem is calculate the number of turns required to produce a flux of 2.5 milliweber in the core of magnetic circuit shown in the figure below. Assume no magnetic leakage and mu r equal to 515, area is equal to 10 centimeter square, and this is the air gap, current 6.5, this length is 10 centimeter and this length is 10 centimeter. So first of all, write all the given data, value of phi, I, area, mu r, Lg, and we have to find the number of turns. So Lt equal to 40. So 40 into 10 to the power minus 2. Li equal to Lt minus L is 40 into 10 to the power minus 2 minus 2 into 10 to the power minus 3, that is 0.398 meter. And total EMF equal to EMF of iron plus EMF of air gap. Therefore, phi upon mu naught mu r A into Li plus phi upon mu naught A upon Lg. Put all this value. Then we can get the value of N, and the value of N is 4.66. So you can write this as 849 tons. Guys, if you like the video, please like, subscribe and share. If you have any suggestion related to the question or videos, please comment. We will improve.